Hello all, welcome to the Scripting Wi-Fi Pen Testing Tools in Python series at Pentester Academy. Now in the last videos, we looked at how to uncover hidden SSIDs, right? The first one was a passive technique to search for probe responses, and the second was to use a dictionary-based attack on hidden SSIDs. Now the question arises, is it possible to use Scapy to actually make hidden SSID detection more difficult or even beat it? So in this video, we are going to look at, creating a hidden SSID cloaker or something which might actually make hidden SSID detection more difficult. Now, what is going to be the principle behind this tool? Well, most attack tools, unfortunately, only look at probe response packets from the access point of a hidden SSID network, and based on the SSID they see inside of it, they decloak the network. Now, keep in mind, real-world clients don't care about probe responses unless it's not directed to them. Now, as we saw in the last video, probe requests were easy to spoof, and so are probe responses. So let's go ahead and build our hidden SSID cloaker. So I'm going to go ahead and take the script in the last video, the hidden SSID dictionary.py, and I'm going to save it as cloak SSID because we'll use it as template code. Oops. I'm going to copy this out. Now let's modify cloak SSID.py. Now this is the dictionary, the hidden SSID attack one which we saw the last time. Let's go ahead and make some really quick modifications. I don't need this part. Now we would need to send a probe response on behalf of the access point, which is sending out hidden SSID beacons, which is really the SSID field is all null, and put in some spurious value in there. So let me go ahead. The subtype for a probe response is 5, so I'll change that. Now in a probe response, the destination address is of course a client, right? So I'm going to change address 1 to my MAC, which basically is of some hypothetical client. Now address 2 and address 3 is really the access point's MAC address. So let's take this as input, sys.argv1. Can go back in here, and address 3 also becomes sys.argv1. The next layer of course is going to change from a probe request to a probe response, and the info field would contain this spurious little SSID, which we'd like to insert. Let's say cloaked, right? Could be interesting. And we are going to go ahead and keep the rates and the channel and all of that same, doesn't matter. And this time around, let's actually configure the number of packets as input as well. Let's take that as input, sys.argv2. Pretty much you would want to have this tool run in the background all the time if you want to cloak a production network. Okay, this looks great. Now to actually test this, I have 2 cards on my system. Let me put both of them on monitor mode, start WLAN 1. I'm going to use one card to send out the probe responses and the other to monitor the traffic, right? That way I know trying to send too many packets isn't interfering with my receiving part. WLAN 2. So I have mon0 and mon1. Let me real quick just run arrow dump ng and ensure that both the interfaces are working just fine. Okay, looks like mon 0 requires a reset and so does mon. Okay, mon 1 seems okay. I've had some problems with my card lately. Okay, let me just pause this. Okay, we are back. Now mon 0, mon 1, both of them work. I'm going to monitor the hidden SSID network with arrow dump ng. And I have created the network on channel 8. Now you can clearly see we are monitoring the hidden SSID network, and the interface I'm using for this is mon 1, so I'm going to use mon 0 to send out our attack traffic. Now the first thing, of course, is we need to be on the same channel as the access point. So iwconfig mon 0 channel 8. You could use the IW set of commands as well. Now cloak SSID basically requires the MAC address of the access point as input, right? And the count of packets to send. So here we have cloak SSID. The MAC address of the AP can be picked up from here. If you notice right now, arrow dump ng shows a length 0. Let's paste this. So actually put in 1,000 packets in here. So the packets are being sent. And if you notice, right now the SSID is actually detected as cloaked, right? Fantastic. Now let me pull up our own little detection tool as well. I'll pause the video. So if you recall, we created a tool called Uncover Hidden SSIDs. And in this case, we gave the interface as input, the count of packets to look in for. So I'm going to have uncover hidden SSIDs.py. The interface would be mon 0. Let's put in a large number of packets. And if you notice, we have it detecting the hidden SSID network. Let's restart arrow dump ng again. And now let's run our attack tool. Let's kill it. There you go. This is cloaked. And if you notice, even our tool ends up detecting that the SSID is actually cloaked, right? Funny enough. So you can well imagine you could even create your own little dedicated IDS system which goes on and keeps sending out these packets to confuse tools around, right? Might not be a very scalable approach, but it's fun to see that it actually works, right? Fantastic. So in this video, you saw how easy it is to create a very simple attack tool which can confuse hackers around. Hope you guys enjoyed this video, and if you're having fun at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.